Okay, this is example section 2.4, problem 15. Use the given zero to find all the zeros of the function, given the function and that 1 minus square root of 2i is a zero. So the first thing I'm going to do here is instead of writing Instead of writing 1 minus square root of 2i, I'm going to rewrite this as 1 minus I square root of 2. It's just easier to see that the I is not underneath the square root. Since they tell us that 1 minus square root of 2i is a root, then we also know that its conjugate, 1 plus square root of 2i, is also going to be a 0. And so I'm going to rewrite this as 1 plus I square root of 2. Since we know that these are zeros, then we can use synthetic division. So I'm going to write the coefficients of the polynomial function: 1, negative 6, 14, negative 18, and 9. And we're dividing by x minus c. In this case, c is going to be 1 minus 2i, or you can use 1 plus square root of 2i. I'm going to go ahead and use 1 plus I square root of 2. So we bring down the 1 and multiply. 1 times 1 is 1. And 1 times I square root of 2 is I square root of 2. If we add, then we get negative 6 plus 1 is negative 5 plus I square root of 2. And so our next step is to multiply. I'm going to go ahead and multiply on the side over here. We have 1 plus I square root of 2 times negative 5 plus I square root of 2. 1 times negative 5 is negative 5 plus I square root of 2 minus 5i square root of 2 plus I square root of 4. Simplify. I squared gives me a negative 1. Square root of 4 is 2. This will become minus 4i square root of 2 minus 2, which is negative 7 minus 4i square root of 2. So when we multiply, this is what we get. So this is going to go up here. And add to the 14 will give us a positive 7 minus 4i square root of 2. And our next step is to multiply again. So 1 plus I square root of 2 times 7 minus 4i square root of 2. This would give me 7 minus 4i square root of 2 plus 7i square root of 2 minus 4i squared times square root of 4. Simplify. I squared is negative 1 times a negative 4 would be a positive 4, and the square root of 4 is 2, so we get 8. So that would be 15 plus 3i square root of 2. And that's going to be under the 18 here. So if we add negative 18 plus 15, we get negative 3 plus 3i square root of 2. And we're going to multiply one more time. So we get 1 times negative 3 is negative 3, plus 3i square root of 2 minus 3i square root of 2, plus 3i squared times square root of 4. This is going to be 0. I squared is negative 1 times 3 is negative 3 times 2 is 6. And so we get negative 9. 9 plus negative 9 will give us 0. And since we get 0, then that proves that 1 plus I square root of 2 is going to be a 0. So we start the process all over again, this time using the quotient of x cubed minus 5 plus I square root of 2 x squared plus 7 minus 4i square root of 2 x minus 3 plus 3i square root of 2. And so we're going to divide by 1 minus I square root of 2. My coefficients here are 1, negative 5 plus I square root of 2, 7 minus 4i square root of 2, and negative 3 plus 3i square root of 2. So we bring down the 1 first. 1 times 1 minus I square root of 2 is going to be 1 minus I square root of 2. Simplify. Negative 5 plus 1 is negative 4. I square root of 2 and negative I square root of 2 is 0. Multiply again. Negative 4 times 1 is negative 4. Negative 4 times negative I square root of 2 is positive 4i square root of 2. 7 plus negative 4 is 3. These will cancel. And 3 times 1 is 3. 3 times negative I square root of 2 is negative 3i square root of 2, giving us 0. And so that makes us happy, because that means that this is really a 0 as they told us. And so the quotient that is left is going to be x squared minus 4x plus 3. And so by doing synthetic division, this is going to be quadratic. And so now we have options. You can use the quadratic formula, or you can try to factor. So we get x times x minus 3 minus 1. Set each factor equal to 0. So these are going to be zeros as well. So my 4 zeros, since I have a degree of 4, I should have 4 zeros, are going to be x equals 1 minus I square root of 2, x equals 1 plus I square root of 2, x equals 3, and x equals 1. And so that is all the zeros, the real zeros of the, so these are all the zeros of the polynomial function.